Hey everyone, it's Quintickle here with another video. Today we're going to talk about how I do my calculations extremely quickly. We're first going to talk about addition, which is one of the easiest operations to do, addition. So basically, let's say you have, 57 plus 84. So you could obviously add them the normal way, like 4 plus 7, that's 11, 1 in mind, 8 plus 5, that's 13, with 141. But there is something you can do even better. You can do 50 plus 80 plus 7 plus 4. Now, 5 plus 8, that's 13, so 50 plus 80 is 130, plus 11, and you can calculate that much more easily, being 141. Now, this is a bit complicated, but practice makes perfect. If you try to do them in your head like this, you're going to get better at it. For example, 75 plus 81. That'll be 156. And the way I did it is 70 plus 80 plus 6 is equal to 70 plus 70 plus 16, and that is 140 plus 16, and is equal to 156. Perfect. That's lovely. Now, another operation that you can do using somewhat this method is multiplication. Obviously, on small multiplications, you can have 5 times 7. If you don't remember that it's 35, you can do 7 plus 7 plus plus 7 5 times. But that's not useful. What I am going to show you is how you can calculate 5 times 7 in a much easier manner. If you don't know your multiplication table, well, you can think, what is the 7th number counting from 5 to 5? Well, that's 5, 10, 15, 20, 25, 30, and 35, which means that 5 times 7 is 35. Now, this is just basic maths, but something else you can do, for example, for additions that are very close to 10. For example, let's say you have 5 times 11. Now, obviously, everyone knows that's 55. But there is one thing you can do better. For example, let's say you've got 5 times 11 again, and you can do it 5 times 10 plus 5. This is very effective for bigger numbers like 63 times 11. Now this seems very hard. That's equal to 630 plus 63, and that's 693. This is very useful. Another trick that I really like when using 11 is, and it works with every 2-digit number, is basically, let's say you have 54 times 11. Now, what you can do is, what is 5 plus 4? That's 9. So the answer is 5, 4, and you put their addition in the middle. So the answer will be 594. But you might be wondering, well, what happens if 5 plus 4 would be a 2-digit number, like, 68 times 11? Well, you might think it's 6, 8, and 6 plus 8, that's 14, so it'll be 6,148, but that is not correct. 68 times 11 is equal to 68. You do the addition, and that'll be 4, and you put the 1 that you remained with here. You get 748, and that's how you calculate with the multiplication of 11. Another operation that we can do using these techniques is, well, minus. Basically, let's say you have 54 minus 33. Now everyone knows that's 21, but how can you think about this logically? Well, you've got 50 minus 30 minus 4, no, plus 4 minus 3. And that'll be 20 plus 1, and that's 21. Now, there are lots of things you can do with this, and Also, you have to remember that when you are working with many zeros, you just have to forget about them in multiplication and division. For example, if you've got 5,000 times 3, well, this will be 1, 5, 1, 2, 3, 4, 5. And basically what I did is I forgot that these zeros existed, so I cut them out. And then what is 5 times 3? That's 15, and then I re-added the zeros back in. You can do that with division as well. For example, if you've got 500 divided by, I don't know, 5. I can forget the zeros. Then it's going to be 5 divided by 5. That'll be 1, and we remultiply by 100. Basically put the zeros back, and we get 100. Now, the best thing to do about these things is concatenating them. For example, what is 69 plus 41 times 11? Wait, no. What is 39? 39. Perfect. So, we're going to use the things that we just learned to conclude that this is 80. And using the 11 multiplication that we just learned, we're going to see the fact that the answer is 180. We could have also done 80 times 11 is equal to 800 plus 80, just to check ourselves, obviously. Now, this doesn't help you all that much other than impressing your friends with a few tricks, but if you're trying to learn your multiplication table, I've got some more tricks up my sleeve for you. For example, the multiplication with 2 up to 12 is very easy. You just go from 2 to 2. The 3 is also easy, but what I want to talk about is 9. So what you want to do, for example, let's say this only works for one-digit numbers. Let's say you want to multiply 5 with 9. Now, how would you go about doing that? You're going to draw 10 lines. Well, obviously, you can use your fingers, but I'm drawing the lines because I can't show you my fingers. 7, 8, and you're going to draw 10 lines, and you're going to delete 1, 2, 3, 4, 5. You're going to delete the 5th line completely. And then you're going to count how many lines are here. Well, that's very simple. There are 4. And no, I only drew 9 lines, sorry. And how many lines are here? Well, there are 5, which means that the answer is 45. Let's try again. Let's say 7 times 9. We draw 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We delete the 7th one. 10, 9, 8, 7. We delete it. And we're going to see that here we've got 6 lines. Here we've got 3 lines. And that is 63. So that's the answer. Now, there are many tricks that you can use. These are the ones that I mainly use. And remember, you have to know the perfect squares of the following numbers. 1 through 10. The perfect squares, so all the squares there. You need to know how much is 11 squared, that's 121. You need to know how much is 12 squared, which is 144, sorry. You need to know how much is 13 squared, 169. 14 squared, which is 196, which you can remember basically just reversing these two digits in 13 squared to get 14 squared. You need to know how much 15 squared is, and that is 225, if I'm not wrong. You need to know how much is 16 squared, which is 256. And you need to know them up to 256. And also some trivial ones that I also know, and you should as well. You need to know how much is 20 squared, that's 400. 25 squared, that's 625. You also need to know how much is 30, 40, 50, and 60 squared. Now, the way to calculate these is very simple. You just square the 3, you get 9, and you add 2 zeros. Because it's basically 30 times 30. And you forget the zeros, you get 9, and you re-add them back. As well as with 40, you forget the zeros, you multiply them, you re-add the zeros, you get 1,600. And the same thing, and so on and so on. These are the perfect squares that you need to use. And you might be wondering, well, why would I need something like this? Well, for example, for quickly extracting square roots, for example, if I give you the square root of 256 times 4 times 169 times 196 times 625, you'd sit quite a while trying to think of it. I mean, I know some people that would just go ahead and straight out multiply the numbers. But if you know many squares, then you can just go ahead and write 16 times 2 times 13 times 14 times 25, which happens to be, and I'll tell you exactly how much it is. It's 16 times 2 times, I don't know if you can see this, I'm using a calculator right now because even I can't calculate that much of a sum. It's 100 and, whoops, something happened on my end, sorry for that. It's 145,000. It's 145,600. So these are my thoughts on quick mathematics, like how to solve really quickly long operations. I hope you enjoyed this video. If you did, be sure to leave a like, and if you really enjoyed it, make sure you're subscribed. Maybe even share this with your friends. But thank you for watching. Quintickle out.